Hello, I'm Jonathan Palmer. This is Bunny Heaven. I'm going to go through a quick tutorial and example on the basic technology behind this project. So, we have this slider that lets us pick how many bunnies on the main menu. When we begin to play, we control a dog and we can tell the dog to go places. When the bunnies get close to the dog, they run away. You can also bark. So, how do we accomplish this? You could simply create that many objects and put them within the scene. But I chose a more complicated and more efficient approach. This right now is 20 bunnies modeled on the entire screen. Each of them has their own independent color, and they can move in different directions and have different animations. And if you note, when I get close to a bunny, it will run away. But when it runs away, the speed of its animation is much quicker. For example, so. And note, that is maintaining above 60 FPS with 20 bunnies. Now, let's bring it up to 1,000. This is 1,000 bunnies. Note, we're still maintaining high FPS. The minor amount of bottlenecking that's occurring is because of CPU side calculation that can be threaded, which will happen in the future. So, how did I accomplish all this? I used two techniques, the first of which I call epoch locking, where Unity, by default, supports animation within particle systems, as each of these bunnies is a particle. I bound them within a specific X and Y and Z area, so much so that the scene is flat and two-dimensional. But I also do things such as change the specific age of the bunnies, so that way they animate through a specific subsection of the material that I've assigned. Because you can only give a particle system one material, as you see right here, you can't do more than one direction, unless you do individual subsections of animation. If you note, I have 4 different cardinal directions as you see the bunnies moving. And this is the material that I hand in. So, when a bunny is going to reach a certain age that is below the minimum possible animation for that direction that it's moving, instead of letting it age normally, I revert it to the beginning of that animation frame, or towards the beginning of the sequence of animation. So if it's moving to the right and it's aging along with my mouse, eventually it will move outside of that bound and I just bump it back to the starting age. The downside is these particles won't naturally die, but if you're representing discrete entities, that's probably preferable. As you can see, none of these disappear or reappear in and out, and they're not even doing so when they exit the screen and come back in. If you notice some going up, they'll go up, they'll bounce off of the top, and they'll come back in. Perhaps that would be easier to notice when there are only 20 bunnies. So we see that one off on the side, the yellow one. He's going to come back in. Yep, there he is. These are all being represented discretely. So, that's the first technique, epoch locking. I have examples of code on my website, which is, as you can see, down in the bottom corner, jonathanpalmergd.com. So, next up, let's look at age adjustment. So if you notice, the bunnies move at a standard rate. They have a velocity, and they bounce off of me. So see this bunny, this pink one? He's moving really slowly. But notice when I scare him, he speeds up, and eventually slows back down. They move much more quickly, or they animate much more quickly when they're scared by me. In the same way how you'd expect a bunny that is scared of something to move. It would run faster. So, how do I accomplish this? I force adjust the age of the particle in the same way how I allow it to move. Let me see if I can make this bigger. Not quite. How the bunnies naturally animate through at a rate of the passage of time. I, during my CPU side calculations, adjust the age based on the magnitude of the velocity of the bunny. So much so, if it's moving to the right really, really quickly, I say, you know what, age this a little bit quicker. It'll end up skipping some frames of its animation, but it will go through the overall motion of the animation much quicker. As you notice, this bunny is going that way. Actually, I'll get a better example. Notice how the hindquarters of the bunny move up and down more rapidly, showing the more exaggerated animation, so you can get the illusion that it's moving faster. Or you can get the idea that it's moving faster, even if the animation can't do appropriate justice and loop through the individual frames faster. So, this is Bunny Heaven. I hope you've enjoyed. There were 3 other people working in the project, which is Kathleen Yang, Alex Lobel, and Forrest Schuster. We're looking at taking the game in a vague idle game direction, as you can see the big point counter up at the top, where you get points for interacting with the bunnies, and doing so you can open up a shop and purchase other ways to interact with the environment. The environment's very simplistic right now, and we look to expand that. Thanks for watching!